Hi, this is Mrs. Clark, and this is my video on arithmetic sequences. So fill in your note in your paper on your notebook with me. If you need to pause at any time to catch up, feel free to do so. So we're going to start here talking about arithmetic sequences. We're going to start with two different rules. First is the recursive rule, and the other is the explicit rule. So an arithmetic sequence is a sequence that we've already talked about quite a few times. It has a common difference. So we've used the word common difference before, and that's when we're looking for a pattern that either adds or subtracts. So we can add that on the front here, actually. Adding or subtracting the same number to get the pattern in the sequence. So anytime we're adding or subtracting the same number over and over again, it's an arithmetic sequence. So we have two different formulas that we use. First we have the recursive rule, then we also have the explicit rule. So I'm going to write down the notation, then I'm going to tell you what it means. So recursive rule, notice this n is down below, kind of like an exponent, but it's at the bottom. We call it a sub n. And a sub n equals a sub n minus 1 plus d. So what this means is recursive rule is kind of like explaining your pattern that we've been explaining in words, like it grows by 2, adding 2 each time, or subtracting 5 each time, but it's just showing it in this notation. So this a sub n term is the term that you want. So if you're talking about like the 8th term, it would be that one. This a sub n minus 1, see how it's 1 is subtracted from it? That means it's 1 less than this one, so it's the previous term. And then d we already defined in our vocabulary, and that's our common difference. Okay. So that's just kind of a little bit how the notation looks for recursive, but recursive is really the one that helps you describe how to get to the next term. So I take the term that I have, I add the common difference to it, and that gives me the new term. The explicit rule is different. That's kind of like the rule that we've been working on to help us find any term down the line. So remember when we practiced and did finding figure 808 or finding 507, we needed a formula or a rule to help us do that because it was too long to list it out. So here is the notation for that. It's a sub n equals d, which is our common difference, parentheses n minus 1 plus a sub 1. So remember this n and this 1 should be lower, like an exponent, and small. We're going to define what each of those things are down here. So n is always going to stand for the term number. A sub n would be the nth term. In the sequence. So along those same lines, see how there's a 1 here? That means n is 1, so a sub 1 is the first term. We can put any number in the n spot. Sometimes when we're writing the rule, it'll just have an n. But other times, if we're looking for a specific term, it'll have a number in it. We're going to do an example also. D, as we know, is the common difference. If you need to pause here to catch up and write these things, feel free to do so. Okay. So we're going to look at an example of an arithmetic sequence, 4, 7, and 10. ... So we notice that it is increasing by 3. Continually. So 4 plus 3 is 7, 7 plus 3 is 10. We would do 10 plus 3 to get the next term, which would be 13. So that tells us that our common difference, which is d, is 3. The other piece of information that we need to know is our first term. So the first term in the sequence is this 4 in the front here. So our A1, first term, is 4. So those are the two pieces of information that I need to fill in for my rule. So if we copy down the rule formula again, so we can make sure we line up everything appropriately. a sub n equals d parentheses n minus 1 plus a sub 1. So I always copy down my formula first, then I fill in what needs to get filled in. So a sub n is going to stay because it's a rule. We're going to keep this in there as like our variable. And then d we know is 3, so we're going to fill that in. Parentheses, keep this n because I kept that n, minus 1 plus our a sub 1, which is 4. So there is our rule, but this rule is kind of complicated looking. There's parentheses, there's lots of things going on, so we're going to simplify it down to make it a little bit easier to use. So just like we practiced the other day, and we looked at when a 3 is out here in front, we have to distribute. I'm going to make a note of that over here. We got to distribute that 3 through the parentheses. So 3 times n, 3 times negative 1. So first let me copy down that a sub n equals 3 times n is 3n, 3 times negative 1 is negative 3, and then I'm just going to kind of bring down this plus 4. So we're almost simplified here, but we have to look for like terms. So the next thing we're going to do is combine our like terms. So the only things I have that are like are these two numbers at the end here. So a sub n equals, I'm going to bring down the 3n, and then I'm going to combine this negative 3 plus 4, and when I do that I get 1, so I have plus 1. So this here is our simplified rule for this arithmetic sequence. Now the reason I want this rule is because I want to find other terms down the line, and I don't want to make a big long list and keep adding 3 every time, so I can use this to find any term. So we're going to use it next to find the 6th term. So if I'm finding the 6th term, that means my n is 6. That means all the n's in the equation are going to get replaced with 6. So first let me copy down our rule. A sub n equals 3n plus 1. Then I'm going to put a 6 in each place I see an n. So a sub 6 equals 3 times 6 plus 1. So a sub 6 means I'm looking for the 6th term, and that's what they asked me for here. So the 6th term, a sub 6, equals 3 times 6, which is 18, plus 1, which is 19. So a sub 6 equals 19. So the answer to this, find the 6th term, the 6th term is 19. So that's our final answer. I could use that formula to help me find the 100th term if I wanted to. I could even use it to find the 4th term, even though it's easy to go through in the list. All right, so the next thing we're going to do is look at an example of an arithmetic sequence. So on the next page, we have this little situation. It says, chairs for an orchestra are positioned in a curve with a conductor at the center. The front row has 16 chairs, and the next row has 4 chairs more, and so on. So if you're thinking about a band, if the conductor is standing here, you have a row of people here, and then the next row goes like this, and the next row goes like this. So each row is getting more and more chairs in it. So that the number of chairs in each row can be shown as a sequence. So if we think of the first row, they told us the first row has 16 chairs in it. There are 16 chairs in the first row. And the next row has 4 more chairs. So in row 2, we're going to add 4, and we're going to get 20. And then in row 3, we're going to add 4 more and get 24, and so on. In row 4, it'll be 28. In row 5, we'll have 32. And then in row 6, we will have 36. So if I want to pull out the sequence I'm going to be looking at is not the rows, or not the figure number, or not the term number, but the number of chairs. So our sequence is going to be 16, 20, 24, 28, 32, and 36. And I'm going to put a dot, 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 because we don't know how many rows there are in this band or orchestra. So my recursive rule in words is going to be looking at how do I get to the next term. So we know that each time we added 4, so we're going to say add 4 to get the next term. And now we're going to write our explicit rule for the situation. So 2 pieces of information we need. We need to know our common difference, and we need to know our first term. So our common difference is adding 4, so it's a positive 4. Our first term was 16, because that was in the first row. So A1 equals 16. So let's copy down that formula for the recursive rule. A sub n equals d parentheses n minus 1 plus a sub 1. A sub n equals d, which we know is 4, parentheses, n minus 1, plus 16. Now we can go ahead and simplify like we did in the last one. So we're going to distribute a sub n equals 4 times n, which is 4n. 4 times negative 1 is negative 4, plus 16. Now we're going to combine our like terms. A sub n equals 4n plus 12. So our rule for this sequence is 4 times n plus 12. I want to graph that just to see what we can see, so we can see what it looks like. We're going to make a graph with our number of chairs on the y-axis and our number of rows on the x-axis. So I'm going to spread out the number of rows. I'm going to go every other box and make 1, 2, 3, 4, 5. We have 6 in our table, so I'm going to go at least that far. And then on the y-axis, I am going to probably count by 4s so I can fit all of them. So each box I'm going to make 4, then 8, 12, 16. I'm going to keep going all the way past 36. So I can make it, I'll maybe go to 44. Okay, so remembering that this point right here is 0 for both the x and the y-axis, I'm going to go ahead and make points. So I'm going to look at my table. In row 1 there were 16, so I'm going to go to 1 and I'm going to go up to 16 and I'm going to make a point. These are the types of graphs that we do in algebra. We don't use bar charts. So we're really going to be looking at, most students call them line graphs, but they're really scatter plots. In row 2 there were 20, so make a dot there. In row 3 there were 24. In row 4 there were 28. In row 5 there were 32. In row 6 there were 36. So if you look at the points on the graph, they're kind of making a straight line. We don't have to connect them or anything. We can just leave the points there. But that's what your graph should look like. So go ahead and feel free to rewind back to anything that I was going too fast or you want to listen to again. You're going to glue this into your notebook on page 22. And if you have any questions, please let me know. Thank you for watching. I did also make this worksheet to go into your notebook on the next page, 23. So it kind of explains the difference between recursive and explicit because it can be kind of confusing. So you can cut this out and put it in on page 23. Recursive rule is a rule to get to the next term from the previous term. So you can add, subtract, multiply, or divide a common number if you're looking at a general pattern. Here's the example that we did with rows and chairs. We talked about pulling out the sequence was 16, 20, 24, 28, 32. Continues on. And then our recursive rule in words, remember, was to add 4 each time to get to the next term. And then down here we have the explicit rule, a rule to help us find any term in a sequence. We have 2 types of rules. We have arithmetic, which you just went over, and we have geometric. So arithmetic is when there's always a common difference, and geometric is when there's always a common ratio. So we will look at geometric more specifically after we practice with arithmetic rules. So this can get put in on your page 23, which is titled Types of Sequences.